All right, so today's lesson, and this is it's kind of funny because while this is a lesson for chapter 5, it's kind of a review lesson. And what you'll see is something's going to pop up when it comes to complex fractions while we're doing things like unit rates, proportions, things like that. And so when it pops up as what's called a complex fraction, you'll understand truly what it is. And that's kind of what today is. It's kind of like it's a filler. It's a crucial lesson, but it's a filler lesson in my opinion. So here's what we're going to talk about. So here we go. Complex fraction is our first word. So complex fraction, everyone?
Complex fraction.
So here's what a complex fraction is. It's a fraction with a numerator and or a denominator that's also a fraction. So for example, in your little box there, go ahead and write this down. 3/4 over 1/2. The numerator is a fraction, it's 3/4. The denominator is a fraction, it's 1/2. So they are fractions within fractions. Now, before we get started, I just want to make sure that that you guys are careful on tonight's assignments. Okay? Here's why. Because if you take a look, when I wrote this down right here, you could clearly see the middle line separating the main numerator from the denominator. Okay? I made it really large. Be careful though, because in your book, this line is only going to be slightly bigger than these two lines. And if you look at it quickly, you may miss up and it may look different to you. All right? So just make sure you pay close attention to which line is the bigger line, because that is, of course, separating the numerator, the true numerator from the denominator. Okay? So just be careful. All right? Here we go. Let's go ahead and go to our examples. And let's check out in book page 197. Book page 197. So if you don't have your paper out already, bless you, go ahead and put first, last name up at the top, period, book page, all that good stuff. Yeah. Okay. Here we go. Problem number 14. All right. So, number 14 is the numerator is 2. If you see what I'm saying, if you look carefully, the one under 2 is actually a little bit bigger than the other. It's 2 and over 3/11. Now, listen. They want us, it says, simple directions. Simplify. Okay? Now, let's take a break here and let's go back to 6th and even some basic 7th grade math. If you have that improper fraction and it says to simplify, what would it simplify to, you guys? 3, right? Some people said 3/1, which is true, but that would even go further to just 3. What is this truly? What did you just do?
A division sign.
It's a division sign you just divided. So ladies and gentlemen, this is all part of step 1. Rewrite this as a division problem. This is just 2 divided by 3/11. That's all this is. Now be very careful. The numerator is your first, if you're writing it out like this, the numerator is your first number. Okay? It's your dividend, and that is your divisor. All right, so here we go. After we write it out, now, at this point, I'm just going to go ahead and put solve. So just a little reminder on when we're solving this. All right, make sure, of course, you have a over b form, meaning a number over a number. So 2 over 1 divided by 3/11. And then remember the best way to divide, you can't divide straight across. You can multiply, but the only way you can multiply it is if you do KFC, right? You keep the first, you flip the second, meaning write the reciprocal of the second number and change the sign to multiplication. At this point, you can cross reduce if you want, but on this one we cannot. So when I multiply straight across, I get 22/3. Okay. Now, if you're dying to do more work, you're more than welcome to write it as a mixed number. 3 goes into 22 7 times, which would be 21, of course, and that there would be one remainder, a remainder of 1, I mean. So either one of those would be okay. So 2 over 3/11 simplifies to 22/3, or 7 1/3. Okay, questions? You do not have to turn into, only if it's a word problem. That's when I require you to turn into a mixed number. Otherwise, I'm okay with either one. Okay?
If it's something like 17 over 1, do you want us to put it as a whole number?
Please put it as a whole number, yes. All right, any others? All right, here we go. Problem 18. Problem 18. Go. Okay, guys, how many of you guys are still working? All right. Check with you guys in about 20 seconds or so. Okay. All right, 30 seconds. Go ahead and share the answer with your neighbor. All right, here we go. Let's take a look at problem 18. Before we do, I just want to see what answers are out there. All right, so seat number 28. 2 over 45? 2/45, like that? Okay, agree, disagree. What do you guys think? All right. So everyone's agreeing. Okay. Anyone with a different answer they would like to share? All right, let's check it out. So problem number 18 is 2/5 over 9. So what we have, order matters, right? 2/5 divided by 9, or 9 over 1. I'm going to go ahead, use KFC. We have 2/5 times 1 over 9. And when I take a look here, can't cross reduce, so 2 times 1 is 2. 5 times 9 is 45. And there we go. Good job. Questions? Okay. I heard some people say, oh, this is easy, but it's going to get harder, I bet. Okay, well, you're partially right, but not much. All right, so here we go. Let's take a look at problem number 30. Now, what we have here is we have percents. And it says write each percent as a fraction in simplest form. Okay? Now, you might say, well, okay, but what does this have to do with complex fractions? Well, first of all, Okay, a little review on elementary school math. Let's take a look. Let's talk about the number 17%. Now, first of all, I do want to share this. There is such a thing as like 17.5%. You say, but Mr. Wilkins, there's a decimal and a percent. Well, that's true, but this is still percent form. Okay, if there's a percent sign there. It's basically halfway between 17% and 18%. And of course, saying that, right, you could also have something like 17.5%. Of course, that's what we're talking about. Okay, so when it's, if they're talking, these problems are talking about changing it into fraction form, you might say, well, Mr. Wilkins, look at number 30. There's already a fraction there. Okay, and that's true, but it's not in fraction form. Okay, now let's go back to this 17% here. How would you convert that to a fraction back in elementary school? What would you do?
17 over 100.
17 over 100. The word percent is actually per cent, cent being a root word of 100 or hundreds. So it's 17 out of 100. Okay, ladies and gentlemen, if we have 15 and 3/5 percent, watch this. Step 1. You're taking the number, no matter if there's a fraction or not, and placing it over 100. Ta-da! Complex fraction. Now what we do, of course, is step 2, and step 2 is just like step 1 was up here, and that is we're going to go ahead and write it as a division problem. 15 and 3/5 divided by 100. Okay, I'm going to go ahead and convert both of these to a number over a number. So 15 times 5 is 75, plus 3 is 78. 78 over 5, divided by 100 over 1. And then I'm going to go ahead and do a little KFC. 78 over 5 times 1 over 100. And now, at the very least, these are even numbers, so we can divide them by 2. So 100 divided by 2 is 50. 78 divided by 2 is 39. All right. So I'm going to go ahead and simplify. 39 times 1 is 39. 5 times 50 is 250. I'm looking at this, and I know that 3 can divide into this, but if I add up the digits to 250, that's 2 plus 5 is 7 plus 0 is 7. 7 can't be divided by 3, so 3 can't go into 250. Okay. I know that 3 goes into 39 13 times, but if I use my calculator, 250 divided by 13, it doesn't go in evenly. This, everyone, is our simplified answer. Okay, so there's only one step before you do the rest of this, that is just converting your percent to a fraction form, and then, of course, simplifying it. So any questions? All right, try out then problem number 32. Problem 32, go. Okay, how many of you are still working on it? Okay. Check in with you guys in another 30 seconds. Okay, how many of you are still in need of more time? Okay, we'll share in about 20 to 30 seconds from now. Again, those of you that understand it, just keep going on your homework. Okay. All right, 30 seconds. Go ahead and turn to your neighbor and share. Go. Okay, here we go. Let me find out an answer that's out there. So, 2 2/5% in fraction form. C40 is not in this class. C20. C20. Three over what? 125. Okay, agree, disagree with that one. What do you guys think? All right, looks like almost all of you guys are on the same page. Let's check this out. So here we go. Step one, right, is take your mixed number here, put it over 100. Step two is let's go ahead and write out our problem. So 2 2/5 divided by 100. Change it to A over B form. So 10 and 2 is 12 over 5 divided by 100 over 1. KFC says 12 over 5 times 1 over 100. If I go ahead and cross reduce, I'm going to go ahead and say, okay, well, 12 and 100. You know what I'm thinking? I was thinking 2, but actually I could split them after 2. I can divide them by 2 again, meaning I can divide both of them by 4. So 12 divided by 4 is 3. 100 divided by 4 is like having 4 quarters, right? It's 25. So when I go ahead and simplify straight across, 3 times 1 is 3. 4 times 25 is 100. With an extra 25, right? It's 125. Well done, ladies and gentlemen. All right. Questions on percents. Simplifying or converting percents to fractions. Okay, here we go. One other type of problem we're going to see. Let's take a look at problem 26. Okay, problem 26. Let's go ahead and close read that. A small airplane used 4 3/8 gallons of fuel to fly a 1 1/4 hour trip. How many gallons were used each hour? Okay, so here we go. First off, I am going to take these two. This, ladies and gentlemen, is a unit rate problem. I'm going to go ahead and write my rate first, which is 4 3/8 gallons. This is step 1. Write your rate. 4 3/8 gallons over 1 1/4 hours. It turns around and the question says, how many gallons were used each hour? That each is just like the word per. So I'm going to go ahead, step 2, I'm going to write my proportion using a unit rate. So gallons on top, hours on the bottom. And remember, it's per hour for each hour, which means the bottom is 1. So here's all I'm doing. We start with our rate being the complex fraction, but what we're doing is we're dividing both top and bottom by 1 1/4. So this is our problem right here. 4 3/8 divided by 1 1/4. So 4 3/8 divided by 1 1/4. So that's converting both these to improper fractions. That's 32 plus 3 is 35 over 8 divided by, and that's 4 plus 1 is 5 over 4. I go ahead, KFC, where I can change it to a multiplication problem, so it becomes 4/5. Change that to multiplication. And sorry, ladies and gentlemen, I am doing step 3 right now. And this is nice because I can actually cross reduce. 4 and 8 can both be reduced by 4. So 1 and a 2. A 35 and a 5 can both be reduced by 5, so a 1 and a 7. Multiply straight across, I get 7 halves. Now be careful, I'm going to go ahead and call this step 4, and that is, this is a word problem, so I'm going to go ahead and change this to a mixed number. So 2 goes into 7 without going over 3 times. 3 times 2 is 6, right? So there'd be a remainder of 1. So 7 halves is the same as 3 and a half. So we're going to say step 5. Again, being a word problem, we need units. And in this case, the question is asking how many gallons were used each hour. So here we go. 3 and a half. And if you want to know, do this. Put it back up in your problem. 3 and a half gallons, right? And there's our answer, but we just need to put it in sentence form. 3 and a half gallons per hour. And there's our answer. All right, questions on that one? Any questions on word problems? Okay, guys, complex fractions.